So we're looking at the next question, and it reads that Millington is holding the string of a kite which is flying 30 meters above the ground. His height is 1.5 meters. The string is straight and its length is 35 meters. So here we have Millington, who has a height of 1.5 meters, and he's holding the string here, and the string's length is 35 meters. So the kite at the end of the string here is 30 meters above the ground, as we can see here, indicated by this drawing here. So the kite is here and it's 30 meters above the ground, and this is the length of the string of the kite, and this is where Millington is actually holding the kite, and this is Millington here. This is his height. Now what we're asked to do is to calculate the angle between the angle x, which is between the string of the kite and the horizontal ground. Now notice that this line here forms an angle with the string of x degrees, and we need to find what that x is. So even though it says and the ground, it's not necessarily have to be this line that we're looking at. This line can represent the ground, because if I were to draw a line here, the angle that this horizontal line will make with the string will be the same as x. So if I were to extend the string to the ground, the angle that this string will make with this ground will actually be the same as this angle here, because they will be corresponding angles which are equal. So hope you get that clear. Nevertheless, let's go into look at how we calculate the angle here. So to find the angle here, we need to recognize that this is a right angled triangle indicated by this right angle sign, horizontal line meeting a vertical line creates 90 degrees angle. So opposite this angle, which is an acute angle, an angle less than 90, we have this side, which is the opposite side. So the acute angle faces the opposite side. And opposite the right angle, we have what is known as what? The hypotenuse. Now, if this is new to you, check out the other videos in the description, starting from the first video, the first link. So opposite and hypotenuse, which ratio that should be? If you said sine, then you're correct. Sine theta is equal to the opposite over the hypotenuse. Remember, these formulae are actually given in your exam. So the sine of theta, in this case, theta is our acute angle, so we're going to replace theta there with the x. So opposite is 30 meters, and hypotenuse is 35 meters. So meters cancel meter, and we can just simply transpose the sine. Whenever you try to find an acute angle, we're going to use the inverse of the trig ratio. So what we'll have is that the angle x will be equal to the inverse sine. The inverse sine, I put a bracket. Ensure you have a bracket. 30 divided by 35. If you don't, then you might get an error. So sine inverse of 30 divided by 35. Enter that in your calculator. You're going to press the shift button, or second function button. Then you press sine, which you should see sine inverse on your screen. And then with the open bracket, if you don't see one, put your open bracket, 30 divided by 35, close bracket, and then you should get an angle of x equal 58.9972, etc. degrees.